Hello everyone, this is our project on autonomous package delivery robot in convoluted factory floor. My name is Toas Dake and my project partner is Shiva Makhauri.
Hi everyone. So RL is an algorithm we intuitively follow in our day-to-day lives. For example, when we're trying to learn some concept, we learn it in a reward and punishment mechanism. If we are learning something, if we are doing something correctly, we reward ourselves, or if we are not doing something correctly, we get a punishment. On basis of this mechanism, we kind of learn through the process. In this project, we are basically using RL algorithm to have a turtle bot move from point A to point B and deliver package to point B.
So our motivation is to increase automation. We have to reduce dependency on human beings. If we reduce dependency on humans, great things can happen like increase in productivity and reduce in product cost. The another motivation is like the reinforcement learning is future for most of the AI applications. For example, the implementation of Google for autonomous navigation in self-driving cars. So we took this opportunity to improve our skills in this topic.
Hi guys, so I'm Shivam. I have 3+ years of professional experience in AI. I worked across two different companies.
I am Toyas and I am grad student in UMCB and really enjoying robotics here.
So as Toyas pointed out, RL is one of the core mechanisms by which major companies try to do self-navigation. So so I'm basically trying to explain it in give a top level view for this. So in RL, basically an agent basically performs an action, observes the environment, performs an action, and then gets a rewards or punishment for that action. This process is done iteratively, and its main objective is to gain maximum cumulative reward.
So this is our class diagram. It basically consists of three classes: navigation, turtlebot states, and queue learning. Navigation is responsible for all the actions that turtlebot takes. The turtlebot states is responsible for sensing the environment, and queue learning is responsible for all the reinforcement learning mechanisms. This is our activity diagram. It is basically divided into two major sections. One is training and one is testing. This is the training part. Basically, the robot spawns at the origin inside the gazebo environment. If the user wants to continue the training, the robot enters into training loop, and if the user is satisfied with the training, it will exit and store the reinforcement learning model. Inside the training loop, the robot will try to predict a step based on a random probability function. Take the step. If it is a proper step, it will get a reward or receive a punishment, and then check if collision is occurred. If the collision is occurred, then the loop will exit, and the environment will reset. Else it will predict next step.
During the inference step, the agent basically uses the knowledge it learned during the training process, loads the model, and performs an action based on the state and input that it's getting.
So this is our demonstration of build steps. We have kept it pretty similar to what we done in assignments. Just run catkin make, and for unit testing, run catkin make space run tests. So as you can see, all the test cases will get passed.
During the training process, the Turtlebot spawns at origin and then forms an action. For example, in this video, you'll see that a Turtlebot spawns and turns a right. So it gets reward for that. This continues until it hits the wall and gets a punishment and then resets the environment. This process is done iteratively, and the main objective during training is to get maximum cumulative rewards for it to navigate properly through the gazebo world.
This is our inference video. The robot loads the RL model from its memory, and as you can see, it will navigate to the initial position, wait for the user to put a payload, and after receiving the payload, it will depart for point B. To reach the point B, it will use its learn RL model to avoid obstacles and navigate through the floor to reach the final destination point.
So we are using something called Q learning approach, RL approach in this project, but there's a future scope in which we are trying to look into actor critic policy, in which an actor produces an action and critic criticizes it, which really improves accuracy as per the research. We are using just laser scan data as input as observation set, but we need but a fusion of sensor inputs and as well as vision system can be really helpful. Overall, using the concepts that we just told about can really help us in in implementing a self-navigating turtle bot.